Today we are going to take a closer look to the internals of this Pace MBT rework station. It was designed for heavy industrial rework situations. It has 3 outputs and a vacuum pump for another kind of desoldering handpiece. It is also used by hobbyists and makers, so we can also call this station as a base maker. And now let's try to disassemble it to see what's inside. It has 3 separate outputs, as you can see, but only one at a time can be used, unfortunately. So this station is a one man, one cup scenery. So it has a fine handpiece with heated tip and with vacuum used to desolder through-hole components. I think this model in the 90s was very popular. But even today is used in the industry. So actually this unit is fully functional. It works as a charm, but I don't have a handpiece for it. Probably in the next episode we are going to adapt a Gordak handpiece. Let's see, that's it. Take out the screws from the back side, as such. Look at this. The screw, it doesn't focus. So the screw from the back is exactly identical with the screw in the front, and you don't really see things like this if you take apart something. It has a foot operated switch also. Oh. As I mentioned, it is kind of tricky to take apart since both sides, both front panels, I mean the back and the front panel, are the same exact pieces of metal, and you have to, I don't know how to show it, you have to take this part and slide through it, but as you can see, there's that big transformer and something happened to this station since, can you see the connectors? They are come a bit apart, but nothing serious. As I mentioned, this is a fully functional unit, but it's an old one. Here is, okay, the switch for the calibration, and now let's try to fucking hell, to take this out. It's not going to be easy, I think. So this is the back side of it, and of course the green PCB can be moved easily. It out and take a closer look to it. So yeah, push it. All right. It comes out nice and easy, and that's it. There's a nice extruded aluminium case, I think. I believe so. But which one is the back and which one is the front? Well, it doesn't really matter, but I think either this way or this way. I think this way. So this is the back side of the PCB. I don't understand this. Maybe it's the date when it was produced. And if we try to not destroy it, it would be really nice. Okay, I found it. So you just take out this. Fits only one way back, and take out this one. But this is tricky. Let's have a marking on it. Here. Okay. Now, if we turn it like that, we can see the main PCB of it. So, after successfully managing to take out the main board, look, such a huge board for just a soldering station. It has quite a 90s style with these resistor network. Actually, I think these are used for pull-up, as a pull-up resistor for line. Current limiting resistors, some other kind of resistor network, I think. I don't really see what it's written on that. Maybe 330 ohm resistor networks. Some triacs and triac drivers, capacitors, but let's talk about this later. And as you can see, this is the back plate of it with a transformer. Nice transformer, Galaxy transformer. And it's written on it Pace. The vacuum pump motor with a flyback on it, I think. And the front panel from the back side, the back of the front. Nothing interesting, just a few buttons and an LED display. And look, it is hand marked which tube sucks and which takes the air out. As you know, this is the hole where you have to fit the handpiece, the main switch. I don't really like this switch. Okay. And that's it. Take a bit to the side the huge mechanical parts. Yep, like there. Oh, by the way, the vacuum pump stays on some rubber bands, so it doesn't vibrate that much. And yep. So this is the main board, as I mentioned before, and yep, it was made, or at least designed, in the 90s. Revision C. A nice double-sided PCB. With the input and rush limiting, or maybe power protection, thermistors. Yes, I don't know how well can you see it. It's written PTC3 and PTC1, and probably it has to be somewhere PTC2. Yep, that's there. So if we take a sheet from the schematic of it, because I have also managed to print out the schematic. So something like, let's hold it like this, I don't know how well it can be seen. So it has multiple power rails, a 5 volt, I don't know how well it can be seen. So 5 volt one, and it's ground. A plus and minus 12 volts. A plus 15 volts and 26 and 21, but these are DC and regulated, or to be more specific, only these three are regulated. The plus 15, plus 26, and plus 21 volt AC. Probably this one is fed to the filaments of the handpiece to heat up the tip. Probably these ones are used for reference, or maybe supplying an op-amp for measuring the tip temperature. Plus 5 volt probably for the microcontroller here, which is a huge, it's surely it is 19th design or late 80s, because nowadays microcontrollers are much smaller, at least their footprint and package. Yep, there it is. And other 5 volts for other kind of logic chips. Plus 12, let's see it. So on the next sheet, and don't get to the next sheet, we have the classical LM320 in the negative, and LM340 for the positive. 5 volt variant regulators, or maybe better known, the 7805 and their 7812 for the positive, 7912 for the negative, and so on. Negative, positive, yep, with some capacitors before and after the regulator, the diode bridge, the full bridge rectifier, the PDCs, and these are used for some kind of short circuit protection, since if it's a positive temperature coefficient thermistor, the higher the current, the higher the resistance. So the hotter it gets, the more resistance it has. Like this one. It's quite interesting to have something that gets hot, maybe in case of malfunction, next to a plastic connector, but okay. These are the big diodes for the other unregulated rails. The two diode bridges here and there with the capacitors. and these small ones are the LM. Can you see it now? These are the regulators, linear regulators. These two, and the third one maybe so Q20. So Q20 we don't even have here. Maybe the schematic is it's for another revision, since this is rev line underscore underscore. I think we can go to maybe the next sheet. Nope, we have also something interesting to talk about. The motor control circuit, which operates the pump. As you can see, both from the front panel and both from the back panel. In the back panel you can connect a foot operated switch, and from the front panel you can operate it manually if you have a switch in the handpiece that is heating up and has vacuum possibilities. As you can see, this is a Darlington transistor for the motor. Also there some logic chips, logic circuits for debouncing it, some driver from the transistors. Oh, and that's it. Go to the next page. So the microcontroller that we were talking about, this one, nothing interesting, some digital logic ICs and pull-up resistor network. As I said it before, one of these, some quartz for setting the frequency of it, with its decoupling capacitors, and that's our crystal. Oh, sorry, that green one. I mean, better said, that blue one. And some voltage reference. Not. So these are the drivers for the three handpieces. So first, the third, second, and first channel. I don't know how well can it be seen, this part of the schematic. So I tried to redraw it. I made it worse. Okay. So this one is a 2N3904. This is some kind of triac, and the whole thing it works in a very general and easy way. So the microcontroller measures the temperature, and when it's under the set point, so if we say this is the set, and if it's under, then then it tells this triac to be turned on, the temperature rises, and it measures again, and if it's over the set point temperature, then it's turned off and on and on and off and on and off. I see some schematics also for these kind of filament heating, where they used phase chopping with zero crossing detection, but that can cause some serious noise on the power lines, and this is a much better way to drive a triac for heating. And some pull-up resistor network also there, the speaker, the diode for the speaker. As you can see it, if you put these two circuits together, then it becomes one. You see, we have put them together like this. Yep, so you got the idea. It's some kind of a general, the main board display, the connectors here and there, transformer with a pump, and the front panel connections, and the power switch. Oh, by the way, the pinout of these ones is quite easy to understand and to remember. So, as you are holding this board, like this, we have more holes. So we have 1, 2, 3, 4, 5, 6. It's a 6-pin. Again, 1, 2, 3, 4, 5, 6 is a 6-pin DIN connector. Only one way, only one possible direction to put something inside there. Yep. And on these two, the temperature dependent resistor, the tip temperature is measured. With the connectors, as I said, it has 6. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So pin 1 with P4. So pin 1 with 4. The thermistor, the temperature dependent resistor, the tip temperature is measured by those two pins. Pin 2 with 5 temp. Pin 2 with pin 5 operates the heater. And 3 together with 6. So 3 together with 6 operates the pump. That's it. I think this pinout is going to be useful for someone, and we are going to come back to this later. Okay, that's my only mention to this part of the schematic, and we go to the last one, the most interesting one. I believe so. So, since LM324 was invented, it is used everywhere. Also here. It is a general purpose operational amplifier with 4 op-amps in it. And as you can see, the first gate is used as a voltage reference buffer together here. So this is the Zener diode, usually a 2-volt Zener diode with 2 capacitors and a current limiting resistor. So in this point we have 2 volts which gets buffered. Also 2 volts gets buffered by this gate, this op-amp, and it's fed to TL500C, which is an analog digital converter, which is then connected to the microcontroller. And that's how... Okay, let's talk about it later. So as you can see, the ref pin gets a 2-volt reference, which means if the ADC gets a 2-volt reference, then the maximum voltage then it can measure it's 2 volts in general. Okay. And the other 2 op-amps from the LM324 are used for temperature measurement. As you can see, channel 1 RTD, channel 2 RTD, and channel 3 RTD. Yep, the whole 2-volt reference voltage gets fed to all of these 3 op-amps, and their output is getting into the DG212 CG, which is just an analog multiplexer, a very simple analog multiplexer. It's a 3-to-1 multiplexer. It is used, it's better said, it's used as a 3-to-1 MUX, and its output gets fed to the ADC somewhere there. These are the 3 triacs used to control the 3 heaters. They're opto triacs. The operational amplifier here, the switch, the ADC, the Darlington, I see, and that's it. These ones are used to control the triacs. Now let's try to assemble it back and turn it on. Well, as tricky as it was to disassemble, as tricky it's going to be to assemble it. I hope I'm not going to break it, since this unit is not mine. I just got it from a friend. That's it. Thanks for watching. Don't forget to subscribe, or hit the like button at least, if you found it a little bit useful, this movie, and thanks. Goodbye.